In this video I'm going to be showing you how to put together a low-cost Hackintosh for less than €450 that runs macOS Sequoia flawlessly and comfortably outperforms the base Apple Silicon Macs in tasks like video editing, photo editing and gaming. This Hackintosh is running the latest macOS Sequoia and it's based around an Intel B760 chipset motherboard with a 13th gen Intel CPU and an AMD graphics card. It's also a real beast when it comes to photo and video editing, all while costing under €450. In this video I'm going to be showing you the parts I used for the build, the installation process for macOS Sequoia, and taking a look at how it compares to Apple's base M1, M2 and M4 Macs in terms of performance. For the motherboard I went with a Gigabyte B760M DS3H. I've reviewed this board previously in a separate video and it's one of the best price to performance socket 1700 boards available. This board costs €93 and for that you get 2 PCI Express Gen 4 NVMe slots for SSDs, 4 DDR4 RAM slots, 2.5GB Ethernet, and a single 16-lane PCI Express Gen 4 slot for a graphics card. The CPU is an Intel Core i3-13100F. This CPU has 4 cores and 8 threads running at 3.4 GHz. I could have gone with a slightly newer 14100F, but at the time of making this video, the 14100F was about 15 to 20% more expensive, while only being about 5% faster. So from a price to performance perspective, the 13100F is simply better value. The case is the Knox Hummer Zero in white. I've used this exact case before in a previous Hackintosh build, and 2 years later this is still the cleanest minimalist white case I've seen at this price point. For the SSD, I've gone with a Western Digital Black SN770 1TB. macOS can be quite particular about which SSDs it'll play nicely with. Samsung SSDs in particular are known to cause problems, but this SN770 works flawlessly in macOS and with its PCI Express Gen 4 interface can reach transfer rates in excess of 5000 megabytes per second. For the RAM, I'm using 16GB of Kingston Fury Beast DDR4 3200. 16GB is still enough for most day-to-day tasks on macOS, and with the motherboard having 4 RAM slots, we can upgrade to 32GB in the future at minimal cost just by buying another couple of RAM sticks. Arguably the most important part of the build is the GPU. I went with an Asus RX 5700 Evo OC with 8GB of GDDR6. AMD Navi cards have been natively supported in macOS since Catalina. The RX 5700 Non-XT hits the sweet spot for price to performance. This is the only part of this build that I bought used and it cost me €115. If you're looking for something a little more power efficient, then an RX 6600 would give equivalent performance, but while pulling only half the power. Finally, the power supply is an EVGA W1 600W. 600 watts is enough to power the GPU and the processor while leaving more than enough headroom to upgrade to a faster CPU or graphics card at a later date without having to upgrade the PSU. Another option is the MSI Mag 650, which costs around the same price of €49. The total cost came to €448. For comparison, that's less than half the cost of an M4 Mac Mini configured with the same 1TB of storage. Now let's get on with the build. I've sped this part of the video up for the sake of brevity. With the PC built and posting, it's time to begin the process of installing macOS Sequoia. The first step is to use another working Hackintosh or a real Mac to download Sequoia using Terminal. Open a new terminal window and type software update list full installers. This will bring up a list of all the installers available for download. At the time of making this video, the most recent version is 15.3. To begin downloading, type software update -- fetch -- full installer -- full installer version 15.3. Hit enter and you'll see a message saying scanning for 15.3 installer, and it should then begin downloading. When it's finished, you'll see a message saying install finished successfully, and if you look in your applications folder, you'll see the macOS Sequoia icon. Now it's time to begin creating the USB stick that we'll be using to install macOS. Take a USB drive at least 32 GB in size and plug it in. Then run disk utility, which you can find in the applications folder under other. Once it runs, go to the view menu and make sure that show all devices is selected. Then select your USB drive under external in the pane on the left and click erase at the top. Choose a name for the drive. I'm just going to call mine Sequoia. The format should be macOS Extended Journaled and the scheme should be GUID partition map. Now click on erase and the drive will be formatted. After it's finished, click on Done and you can quit disk utility. Now we need to write the macOS installer to the USB drive. To do this, we're going to be using create install media in terminal, using this command from the Apple website. There'll be a link to this page down below. Highlight the text under Sequoia and press Command and C to copy it. Then switch back to the terminal window and press Command and V to paste the text you just copied. Delete the text My Volume from the end and replace it with the name you used when you formatted the USB. In my case, Sequoia. Hit enter and you'll be prompted for your password. Type your macOS password, hit enter and you'll be asked if you want to continue. Type Y and press enter again, and create install media will erase the drive and begin creating a bootable installer. This can take a few minutes to complete depending on the speed of your drive. Once it's finished, you'll see a message saying that the install media is now available, and you'll find that your USB drive has been renamed to install macOS Sequoia. Now, before this drive can be used to actually install macOS on our Hackintosh, we need to create the EFI folder. The EFI folder is where the OpenCore bootloader and all of the drivers and files needed to boot macOS are stored. To create this folder, I'll be using a program called OpenCore Auxiliary Tools, or OCAT for short. Go to the OCAT GitHub page, which will be linked down below, and click on the releases on the right. This will bring you to the download page for the latest version. Click on the file name ocat_mac.dmg to save it to your downloads folder. Now open your downloads folder and double click on the DMG to mount it. When the window opens, drag the OC Auxiliary Tools icon into your applications folder. If you try to run OCAT now, you'll see a message like this saying that it couldn't be run because Apple couldn't verify it. To allow it to run, open System Settings, then click on Privacy and Security in the pane on the left. Now scroll down all the way to the bottom and you'll see a message saying that OC Auxiliary Tools was blocked to protect your Mac. Click on the button labelled Open Anyway to the right and then click Open Anyway again in the window that pops up. Then type your macOS password and click OK, and finally OCAT will run. OCAT has links to built-in FE templates for common configurations, but unfortunately they only go up to 10th generation. Since this computer is using a 13th gen CPU, I'll instead be using this template from Fuyu Xuan on GitHub specifically for 12th to 14th gen CPUs. Go to the GitHub page, which will be linked down below, and click on the releases on the right. Then click on efi.zip to download the latest version and save it to your downloads folder. Open your downloads folder, unzip the file and drag the EFI folder to your desktop. Now double click on the folder to open it and then open the OC folder. You'll find that there are 5 plist files inside. Since this computer is using a 13th gen CPU, I only need the Raptor Lake file. Select the other 4, then right click and select Move to Trash, leaving just the Raptor Lake plist. Now rename the file by clicking on the file name and deleting the text after config, leaving it named config.plist. Now double click on the texts folder. There are a few texts in here that aren't needed. I'm going to get rid of CPU friend data provider, CPU topology rebuild, and whatever green. You can leave whatever green if you like, or add it back in later if you experience problems, but I found that the RX 5700 worked perfectly without it, and I'm a firm believer in not including texts that aren't needed. Select the 4 files, right click and select Move to Trash. Now open the additional folder, right click on Lucy RTL 8125 Ethernet.txt and select Copy. Then click back, right click and select Paste Item. This is the driver for the onboard 2.5 gigabit Ethernet on the motherboard. Now click back again and double click on ACPI. There are 2 AML files in this folder that aren't needed. SSDT6X50 Fake ID and SSDT-XH ADLS3. Again, you can select both of these files, right click and select Move to Trash. Now click back again, double click on the config.plist file and OCAT should run. You'll see a message saying that the app would like to access files on your desktop. Click on Allow and the config.plist file will be loaded. Now on the first page under ACPI, you'll see that 2 of the entries have red dots. These are the AML files that we just deleted. Right click on each of them and select Delete Item. Next, select DP on the left. On the right, next to Layout ID, change the value next to number from 1 to 12. This is the layout ID for the onboard audio on the motherboard. Now select Kernel on the left. You'll see a list of all the kernel extensions. Select all of the entries with a red dot, then right click and select Delete Item. And put a tick in the box under Enabled next to Realtek 8125 Ethernet. Now click on MISC on the left and then click Security at the top. Click the little arrow next to Secure Boot Model and select Disabled in the drop-down. Now select NVRAM on the left and click the 3rd hexadecimal number down. Now click on the value next to bootargs and delete the text saying AGD pmod equals Pykera. This is for whatever green, and since I'm not using whatever green, it's not needed. Now click in the box under Data Type next to prevlan KBD and change it from data to string. Then next to it under Value, I'm going to put EN-US:0 to set the language to English US. Now click PI on the left. Next to System Product Name, you can choose which SMBIOS definition to use. Since I'm using a Hackintosh without an integrated GPU, it's important to choose the SMBIOS of a Mac without an iGPU as well, since if macOS expects an iGPU to be present and there isn't one, it'll cause problems. The default is Mac Pro 7,1, which is the 2019 Mac Pro with an Intel Xeon. You can leave it as this, but I'm going to use iMac Pro 1,1, which is the 2017 iMac Pro also with a Xeon processor. Next, click in the box next to processor type, delete the number 3842 and replace it with 2305. This is the correct processor type for the Core i3. Click the button labeled Generate, then click in the serial number box to select it, and press Command and C to copy it to the clipboard. Now we need to make sure that the serial number isn't already in use by a real Mac or another Hackintosh. Open a web browser and go to checkcoverage.apple.com. Click in the box and press Command and V to paste the serial number you just copied. Then complete the captcha below. If you see a message saying please enter a valid serial number like this, then you'll be good to go. Otherwise, you need to click Generate again to generate a new serial number and then try again. And that's it, we're done, and you can click the save icon at the top to save the modified config.plist. Now we just need to copy the EFI folder from the desktop onto the USB drive containing the macOS installer. Click the icon 3rd from the right labelled Mount ESP. Select your USB drive in the window that appears, click on Mount, then type your macOS password and click OK. You'll see the icon for the EFI partition appear on the desktop, and you can just drag the EFI folder icon onto the drive to copy it over. And that's it, the drive's ready to be used to install macOS Sequoia. Plug it into the Hackintosh, turn it on and hit delete to enter the BIOS. Go to the boot section, make sure that Windows 10 features are set to other OS and CSM support is disabled. Then exit and save changes. The Hackintosh should boot from the USB and you'll be greeted with the OpenCore boot selection screen. Choose Install macOS Sequoia and hit enter. After a few seconds, you'll see the language select screen. Choose your language and then click the arrow to continue. When the macOS recovery screen appears, the first thing we need to do is format the SSD. Select Disk Utility and click Continue. When Disk Utility opens, select your SSD in the pane on the left and click Erase at the top. Choose a name for the drive. I'm just going to use the standard Hackintosh HD. The format should be left as APFS and the scheme should be left as GUID partition map. Then click on Erase and the drive will be formatted. Once it's formatted, quit Disk Utility to bring you back to the recovery menu. Now select Install macOS Sequoia, click Continue and then click Continue again to begin the installation process. Click Agree, then Agree again, then select your SSD and click Continue. It'll take a few minutes for macOS to be installed and the PC will reboot a couple of times during the installation. But OpenCore will automatically select the right boot volume to continue the install. When it's finished, go through the initial setup just as you would on a real Mac, and you'll be into a fully working macOS Sequoia. Now it's time to see how this Hackintosh performs, and how it compares to some real Macs with Apple Silicon. First, in Geekbench 6, it scores 2,356 for single core, and 8,355 for multi-core. This is basically identical to the late 2020 M1 Mac Mini and the 2021 M1 iMac. Compared to the M2 Mac Mini, it's about 15% slower in multi-core and 10% slower in single core. And compared to the M4 Mac Mini, it's around 40% slower in both single core and multi-core. But this doesn't tell the whole story. Overall performance depends a lot more on the performance of the GPU rather than the CPU, since basically all creative apps these days use the GPU instead of the CPU for intensive calculations. Whether it's Apple Motion, Final Cut Pro, DaVinci Resolve, Adobe Photoshop or Adobe Lightroom, they all offload the majority of the calculation-intensive workloads onto the GPU rather than the CPU for better performance. That's the Achilles heel of the Apple Silicon Macs and this Hackintosh's strong point. The RX 5700 in this Hackintosh scores 90,410 in the Geekbench 6 metal test. This means that it's nearly 3 times faster than the base M1 Mac Mini, twice as fast as the M2 and 60% faster than the M4. And in the OpenCL benchmark the difference is even greater, with the Hackintosh scoring 70,067, which is more than 3 times higher than the M1, over twice the speed of the M2, and nearly twice as fast as the M4. Another area where this Hackintosh excels is in the storage speed. The SN770 SSD hits 5,200 MB per second for read, and 4,800 MB per second in write. Almost twice the speed of the SSD in the base M4 Mac Mini. And these graphics and storage performance advantages make a real difference in things like photo editing, video editing and gaming. In Lightroom Classic, using the AI denoise feature on a 26 megapixel RAW photo taken on a Fujifilm X-T4, the Hackintosh takes just 14 seconds. This compares to 1 minute and 31 seconds on the M1 Mac Mini, 52 seconds on the M2 and 36 seconds on the M4. When you're working with hundreds of photos, as I often am, saving 22 seconds per photo can quickly add up. Also in Lightroom Classic, exporting 10 26 megapixel RAW photos to JPEG took 6.54 seconds on the Hackintosh, 15.9 seconds on the M1, 13.4 seconds on the M2 and 8.63 seconds on the M4. Again, when you're working with hundreds of photos, these few seconds saved can add up quite fast. Moving on to video editing, in Blackmagic RAW speed test, the Hackintosh scores 39 in 8K CPU and 147 in 8K metal. This is only slightly faster than the M4 in the CPU test, but over twice as fast in the metal test. In Final Cut Pro, exporting an 18-minute 45-second 4K video shot on a GH5 to H.264 took 5 minutes and 58 seconds on the Hackintosh, 14 minutes and 4 seconds on the M1, 9 minutes and 12 seconds on the M2 and 8 minutes and 32 seconds on the M4. And of course it's games where we see the biggest difference. The Mac version of Shadow of the Tomb Raider running at 1080p on high averages 119 frames per second on the Hackintosh. That's nearly 5 times faster than the M1 Mini, 4 times faster than the M2 and 2.5 times faster than the M4. Total War 3 Kingdoms, again at 1080p on high detail, averaged 89 frames per second on the Hackintosh, 20 on the M1 Mini, 27 on the M2 and 41 on the M4. The biggest advantage for games though is that, this being a PC, you can just install Windows on a second SSD and boot into it whenever you want to game. There's no need to limit yourself to the games that have a Mac version available or to use Parallels or Crossover. Just reboot and run Windows games natively at full speed. While I love my M4 Mac Mini, it's incredibly fast and without a doubt the best value Mac Apple have released in the last decade, for me at least, and the things I use my Macs for, like video editing, photo editing and gaming, the Hackintosh is still faster and cheaper. Obviously, to address the elephant in the room, the writing is on the wall for macOS on Intel, and the soon to be released macOS 16 or 26 may well be the last version to support Intel. So that's it for this video. If you have any questions, put them down in the comments below and I'll do my best to answer them. That's it for now, thanks for watching.